Today I'd like to talk about complex fractions. These are sort of fractions within fractions. But before I do that, I want you to look at a little movie thing here. This is called a Mandelbrot set, this graphic here. It is a fractal, which fractals are self-similar at various scales. If you notice around the edges, they're sort of similar to the larger picture there. It's generated by a single equation that comes back on itself and recalculates. Now, Dirac here is pointing at a certain area, and what we're going to do is magnify that. And if you keep magnifying that area, or any area, in fact, in the Mandelbrot set here, it becomes infinitely complex and opens up this beautiful world. And I would like for you to just look at this little world, and I'll just sort of step aside as you look at it. Okay, I hope you enjoyed that. Now, what we're going to do is we're going to go from the more complex to the more simplified. Now, let's look at some of our problems here. Here's our first one. We have sort of a larger fraction and smaller fractions within there. Now, what we need to do to start simplifying that is look for the least common multiple, in this case, of 3 and 6, which are part of our two fractions, 2/3 and 5/6. That happens to be 6. And then it works down to one fraction. So we got 18 minus 4 over 30 minus 5, and we'll get 14/25. In our next case here, the smaller fractions have an x in it, and so what we want to do is find the least common multiple of the numerator and denominator there. It'd be x squared. So multiply x squared times the numerator and denominator of that larger size fraction, and we'll get x squared plus x over x squared minus 1. Now that denominator there is the difference of squares, and that can be factored into the quantity x plus 1 times the quantity x minus 1. And notice that you can then cross out an x plus 1 from the numerator and denominator, and we're left with x over x minus 1. So that's the key thing to do there. Now we look at this one here. We just have a small-sized fraction in the denominator of the large-sized fraction, and if we multiply it a times the numerator and denominator, it'll clear the smaller-sized fraction out and leave us with one fraction. Now notice the denominator there, 4 minus a squared. Let's factor out a negative 1 from there, and then we'll get a squared minus 4, which will again give us the difference of squares. The quantity a minus 2 times the quantity a plus 2, and then we can factor out a minus 2 from the numerator and denominator, and we'll be left with a negative a over a plus 2. Now in our last problem here, the two small-sized fractions both have the same denominator, 2x minus 3. So we can just multiply the large-sized fraction, 2x minus 3 times the numerator and denominator of that. And so that gets it down to one fraction. Now, let's do a little distributive property here. 4 times the quantity 2x minus 3 and 5 times the quantity 2x minus 3. Now, those 12s and 15s will just drop out, and you're left with 8x over 10x. The x's drop out. Divide 2 into the numerator and denominator, and you get 4/5. Thank you.